The central limit theorem. The central limit theorem says that under general conditions, the distribution of big Y bar is well approximated by a normal distribution when n is large. Recall that the mean of big Y is mu sub big Y, and its variance is sigma sub big Y bar squared equals sigma sub big Y squared over n. According to the central limit theorem, when n is large, the distribution of big Y bar is approximately big N of mu sub big Y and sigma sub big Y squared. As discussed at the end of section 2.5, the distribution of big Y bar is exactly big N of mu sub big Y and sigma sub big Y bar squared. When the sample is drawn from a population with the normal distribution big N of mu sub big Y and sigma sub big Y squared, the central limit theorem says that this same result is approximately true when n is large, even if big Y sub 1 through big Y sub n are not themselves normally distributed. The convergence of the distribution of big Y bar to the bell-shaped normal approximation can be seen a bit in figure 2.8. However, because the distribution gets quite tight for large n, this requires some squinting. It would be easier to see if the shape of the distribution of big Y bar, if you used a magnifying glass or had some other way to zoom in or to expand the horizontal axis of the figure. See figure 2.8, sampling distribution of the sample average of n Bernoulli random variables. We have A where n equals 2, and probability ranges from 0.0 to 0.7, and the horizontal axis value of the sample average is 0.0 at 0.25 increments. There's another bar at 0.5 and another bar at 1.0. There's B where n equals 5 and similar structure, and n equals 25 for C, and n equals 100 for figure 2.8D. The distributions are the sampling distributions of big Y bar, the sample average of n independent Bernoulli random variables with p equals the probability of big Y equals 1 equals 0.78. The probability of a short commute is 78%. The variance of the sampling distribution of big Y bar decreases as n gets larger, so the sampling distribution becomes more tightly concentrated around its mean. Mu equals 0.78 as the sample size increases.